Greetings to all space enthusiasts. Today, we're going on an incredible journey deep into time to learn how our solar system was formed. It's a story that spans billions of years and is one of the most fascinating in the study of astronomy. It all started about 4.6 billion years ago. At that time, a huge cloud of gas and dust existed in one region of our galaxy, the Milky Way. This cloud is called the solar nebula. Under the influence of gravity, this giant gas and dust cloud began to shrink. At the center, where the gravitational pressure was greatest, a protostar, our future sun, began to form. When the core of the nebula reached a certain temperature, thermonuclear reactions began. The solar wind from the newborn luminary began to disperse the remaining gas and dust into the surrounding space, and then the sun became the full-fledged star, emitting the light and heat we know today. As the sun continued to heat up, there were remnants of gas and dust around it that began to coalesce into larger formations. This process is called accretion. Over time, these small particles formed planetesimals, the first embryos of planets. Over time, through mutual collisions and gravity, the planetesimals merged to form planets. The inner planets, Mercury, Venus, Earth, and Mars, were formed from heavy elements such as iron and silicon. They became rocky and dense because the solar wind drove the lighter gases and volatile elements farther from the sun. But the outer planets, Jupiter, Saturn, Uranus, and Neptune, formed from ice and gas that were farther from the sun, where temperatures were lower. These planets became giant gas and ice giants with massive atmospheres of hydrogen and helium. As the largest planet in our solar system, Jupiter played an important role in its formation. Its enormous gravity cleaned up the space around it, absorbing many planetesimals or ejecting them outside the solar system. This prevented the formation of another gas planet between Mars and Jupiter, and the remaining material formed the asteroid belt. Jupiter may also have influenced the inner planets. For example, its gravity could have affected the orbits of the planets and even slowed their formation. Without Jupiter, our solar system might look very different. Our planet, Earth, is located in what is known as the habitable zone, a region around the sun where the temperature allows water to exist in liquid form. It is the presence of water that made the Earth habitable. One of the most exciting theories for the formation of the Moon states that it arose after the Earth collided with a hypothetical Mars-sized planetary body called Theia. As a result of this colossal event, a huge amount of material was ejected into space, from which the Moon was eventually formed. Along with planets, there are many small bodies in the solar system: asteroids, comets, and dwarf planets. Asteroids are mostly found in the asteroid belt between Mars and Jupiter, and are remnants of matter from which planets would have formed if not for the influence of Jupiter. Comets, on the other hand, are much farther out, in the so-called Oort cloud. These icy bodies sometimes approach the sun, forming long tails as the ice and gases begin to vaporize under the sun's heat. Pluto was once considered the 9th planet in the solar system, but after the discovery of many other celestial bodies in the Kuiper belt, it was reclassified as a dwarf planet. The Kuiper belt is a region filled with icy bodies and asteroids that lies beyond the orbit of Neptune. Pluto remains one of the most interesting objects to study, especially after the New Horizons mission, which gave us the first detailed images of this distant planet. The solar system continues to evolve. Eventually, in about 5 billion years, the sun will use up its fuel and become a red giant. It will expand and swallow Mercury and possibly Venus. Earth will also be at risk, but it is not yet known for sure whether it will be absorbed or thrown into a more distant orbit. When the sun sheds its outer layers, it will become a white dwarf, a small but very dense star that will take billions of years to cool down. The planets that survive this catastrophe will continue their orbit around the new, dimmer sun. The history of the formation of the solar system is a fascinating process that continues to this day. We continue to learn about the origin and evolution of planets and small bodies, and each new spacecraft and mission. A supernova, the most powerful and spectacular explosion in the universe, is set to light up our skies. When a star goes supernova, it can outshine entire galaxies, producing a brightness visible even during the day. This celestial event occurs when a massive star, at least 8 times the size of our Sun, exhausts its nuclear fuel. Unable to counteract gravity, its core collapses, leading to a colossal explosion. The result can be a neutron star or a black hole, 2 of the universe's most mysterious objects. Historically, supernovae are rare events, while 2 to 12 stars in our Milky Way are expected to go supernova every century. We haven't witnessed such an event in our galaxy for centuries. This makes us overdue for a spectacular cosmic show. Thanks to advanced telescopes, even distant supernovae can be detected, promising a thrilling sight for astronomers and enthusiasts alike. There are 2 main types of supernovae. The first type, a core collapse supernova, happens at the end of a massive star's life. As fusion ceases, the star's core collapses, causing a brilliant explosion. Many known stars fall into this category, such as the blue giant Spica in the Virgo constellation and the red supergiants Betelgeuse in Orion, Antares in Scorpius, and VY Canis Majoris. Each of these stars, located hundreds of light years away, is a potential candidate for a future supernova. The second type occurs in binary systems, where a white dwarf star accumulates material from a companion star until it ignites in a thermonuclear explosion. An example is the recurrent nova T Coronae Borealis, which is predicted to erupt into a supernova by September 2024, located in the constellation Corona Borealis. This system's last eruption was in 1946, making its next explosion highly anticipated. Supernovae not only provide breathtaking celestial displays, but also offer invaluable scientific insights. Studying these events helps us understand stellar life cycles, mass transfer in binary systems, and the evolution of galaxies. The upcoming potential supernovae remind us of the dynamic and ever-changing nature of our universe. When a supernova explodes, it ejects an enormous amount of energy and material into space. These ejecta include heavy elements like gold, silver, and uranium, formed during the explosion and then dispersed throughout the galaxy, enriching the interstellar medium. This enrichment is crucial for the formation of new stars, planets, and eventually the emergence of life. Recorded observations of supernovae date back centuries. One of the most famous is SN 1054, which exploded in 1054 AD. Its remnants, known as the Crab Nebula, are still studied by astronomers today. Chinese astronomers recorded that this supernova was visible during the day for 23 days and at night for almost 2 years. Another significant supernova was SN 1987A, which exploded in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This explosion provided astronomers with a unique opportunity to observe a supernova up close and study its evolution in real time. With modern technology, such as the Hubble Space Telescope and the upcoming Vera Rubin Observatory, we can observe supernovae with unprecedented accuracy. These instruments allow us to study light curves, spectra, and other characteristics of the explosion to understand the physical processes occurring within the star. Supernovae also play a key role in cosmology, helping scientists measure distances to galaxies and determine the rate of expansion of the universe. Type Ia supernovae, resulting from white dwarf explosions, are especially useful for this purpose due to their predictable brightness. With the launch of new observatories and technological advancements, we can expect to discover even more supernovae. For instance, the upcoming launch of the James Webb Space Telescope promises to revolutionize our understanding of stellar explosions with its ability to observe in the infrared and peer into previously inaccessible regions of space. While supernovae in our galaxy are rare, their effects can be significant. The explosion of a nearby supernova could impact Earth, from altering the chemical composition of the upper atmosphere to potential consequences for life on our planet. However, most known potential supernovae are at a safe distance, allowing us to enjoy their spectacle without threat. As we eagerly await these exciting events, we continue to explore the cosmos, hoping to uncover more about the mysterious and fascinating phenomena that shape our understanding of the universe. Stay tuned for updates and prepare for a celestial spectacle that might occur any day now. Are you excited to witness a supernova? Share your thoughts and follow for more cosmic revelations. In anticipation of the next supernova, astronomers are conducting extensive research to better understand the nature of these grand explosions. One promising direction is the study of pre-explosion indicators. For instance, some stars, like Betelgeuse, exhibit variability in brightness and other instabilities that might signal an imminent explosion. Using data collected from ground-based and space telescopes, scientists hope to develop models capable of predicting the time and location of the next supernova. Some of the most exciting discoveries can happen completely unexpectedly. In 2008, astronomers were surprised by the discovery of supernova SN 2008D in the galaxy NGC 2770. The explosion was detected by chance when the Swift telescope was observing another object. This event demonstrated that even with modern technology, we can miss significant cosmic phenomena, making continuous observation and monitoring even more crucial. Supernovae play a key role in the cosmic cycle of life and death of stars. When stars explode, they scatter elements formed in their cores, such as carbon, oxygen, iron, and other heavy elements, into space. These elements become the building blocks for new stars, planets, and even life. To a significant extent, we are all made of star dust, and without supernovae, life as we know it would be impossible. Supernova explosions are also sources of cosmic rays, high-energy particles that travel through the universe. These rays can interact with Earth's magnetic field, causing auroras and influencing climatic and biological processes. Studying cosmic rays emitted by supernovae helps scientists understand the impact of these particles on our planet and life on it. Supernovae can also create gravitational waves, ripples in spacetime predicted by Albert Einstein. Detecting gravitational waves from supernovae could provide new information about the internal processes of these explosions and the properties of neutron stars and black holes formed as a result. Modern observatories, such as LIGO and Virgo, have already recorded gravitational waves from collisions of black holes and neutron stars, and future observations may include supernovae in this list. Modern technology allows us to peer into the farthest corners of the universe. The recently launched James Webb Space Telescope promises to revolutionize astronomy, providing unprecedented data on stars, planets, and galaxies. It can observe the formation of star systems, explore the atmospheres of exoplanets, and capture supernovae at their earliest stages of development. In the coming years, astronomers expect to discover new supernovae thanks to projects like the LSST survey system at the Vera Rubin Observatory. This system will scan the sky every night, creating a detailed map of the universe and identifying changes in real time. This will not only help detect new supernovae, but also monitor their evolution with unprecedented precision. Supernovae also inspire art and science. They often become the subject of science fiction, books, movies, and TV series. Their grand nature and mysterious consequences make supernovae a fascinating subject for imagination and creativity. Movies like Interstellar explore the possible consequences of star explosions and deep space travel, fueling public interest in astronomy and space exploration. With each new discovery, we move closer to understanding the processes governing supernovae and their impact on the universe. Supernovae remain among the most exciting and mysterious phenomena in space. Whether through scientific research, technological breakthroughs, or simple admiration of the beauty of star explosions, they continue to inspire us and drive the exploration of the vast expanses of the cosmos. Stay tuned for updates and be prepared for an exciting cosmic spectacle that could happen at any moment. Perhaps tomorrow we will witness the burst of a new supernova that will forever change our understanding of the universe and our place in it. Personally, I find supernovae among the most exciting and mysterious phenomena in space. Their incredible power and beauty not only impress, but also remind us of how dynamic and unpredictable our universe is. Each explosion is not only the end of a star, but also the beginning of new processes that can lead to the formation of new stars and planets. Ultimately, we are all children of stardust, and supernovae play a key role in this cosmic chain. What do you think is the impact of supernovae on our galaxy? Would you like to see a supernova with your own eyes if given the chance? Are you interested in other astronomical phenomena, and which ones do you find most fascinating? Do you think it is possible to predict supernovae with high accuracy someday? What other cosmic phenomena would you like to explore or learn more about? Don't forget to subscribe to our channel to stay updated on all the latest news and discoveries in the world of astronomy. Your likes and comments help us develop content and share the most exciting and interesting stories from the world of space with you. Share your thoughts in the comments and stay with us for new cosmic adventures. Greetings to all space and movie fans. Today we will take a journey between reality and fantasy to find out where the boundaries of scientific accuracy lie in the legendary Star Wars universe. Many of us, marveled by huge spaceships, lightsabers, and droids, have more than once wondered, is it possible in real life? In this video, we'll not only walk through the iconic elements of Star Wars, but also see how science can or can't make these fantasies a reality. Spaceships hurtling at the speed of light through hyperspace have become one of the most colorful symbols of Star Wars, but is such rapid travel between planets and star systems possible? Reality. In real science, to travel at the speed of light, we would have to overcome the limitations of Einstein's theory of relativity, which states that the mass of an object increases as it approaches the speed of light. Travel in hyperspace would probably require something like warping space itself, as in the space-time warp hypothesis. Alternatives. Modern scientists do discuss hypotheses about the so-called warp drive, but so far this technology is far from being realized and remains at the level of hypotheses. An intriguing question. Is it possible that one day humanity will be able to control the structure of space-time? Is it possible that the future of space travel could be as amazing as Star Wars? Lightsabers. Jedi weapons and physical limitations. The lightsaber is perhaps the most recognizable attribute in the entire Star Wars universe. But is it possible to create this type of weapon in real life? The lightsaber is based on the idea of holding a light beam to a limited length, which contradicts the laws of physics. Light in a vacuum can't just stop, it will keep traveling. Scientists and engineers are already working on plasma and laser-based weapons, but they are difficult to make as compact and energy-intensive as Jedi swords. Lasers also won't stop at a certain length, they will move all the way to extinction, so a true lightsaber would require a physical limiter, as in plasma-based devices. In Star Wars, the Force is a field of energy that allows Jedi to foresee danger, manipulate objects, and even heal others. Is it possible to possess such powers in reality? Science has yet to confirm the existence of any energy force similar to the Force from Star Wars. However, scientists are studying the capabilities of the human brain and its effects on perception, which brings us somewhat closer to understanding the sixth sense. Practices such as meditation help improve concentration and reaction, which can be seen as similar to some aspects of the Force. But such practices do not confer supernatural powers. In Star Wars, we're treated to epic space battles where ships fly, maneuver, and explode with sound. But is this possible in space? There is no sound in a vacuum, as sound waves do not propagate in the absence of air. Therefore, loud explosions and roaring engines in space are pure fantasy. However, modern technology allows us to create impressive visual effects, and in the future, we may be able to create special effects that show space battles in a more scientifically sound manner. In Star Wars, droids like R2-D2 and C-3PO have unique personalities and can perform a wide range of tasks. But how advanced is today's artificial intelligence and robot technology? Modern artificial intelligence already allows us to create robots that can perform complex tasks and even interact with humans. However, the level of emotional and cognitive intelligence of the droids in Star Wars is still a long way off. Interesting developments. Progress in AI is accelerating, and developments such as artificial intelligence with self-learning and emotional adaptation are bringing us closer to a world where droids with unique personalities are possible. The Death Star is one of the most destructive weapons in the Star Wars universe, capable of destroying entire planets. But is it possible to create such a super weapon? Creating such a gigantic weapon would require unimaginable resources and energy. In addition, physically blowing up a planet would be extremely difficult, and even a hypothetical weapon capable of destroying a planet might not be powerful enough. Orbital lasers and superweapons can actually be used for peaceful purposes, such as asteroid defense or supporting space missions. However, for military purposes, their potential destructive power is still far from the Death Star. In Star Wars, characters often travel between planets and different ecosystems with surprising ease. But how realistic is interplanetary travel within our galaxy? We don't yet have the capability for interplanetary travel beyond the solar system, let alone to the far reaches of the galaxy. However, missions to Mars and the establishment of colonies on the Moon are no longer science fiction, but real projects. Missions like Mars One and NASA programs aim to one day send humans to Mars. While it's a far cry from Star Wars, it's the first step toward exploring the stars. Star Wars is known for the diversity of alien races that live in different ecosystems. But are there scientific theories that support the possibility that such races exist? There is currently no evidence for the existence of alien civilizations, but SETI programs continue to search for signals from space. Scientific discoveries show that there may be exoplanets in space with conditions suitable for life. In the world of Star Wars, reality and fantasy merge to create stunning images of the future. While many of the technologies and ideas from this universe seem scientifically impossible, modern advances in science and technology prove that we can get close to some of them. The future will show which of these technologies will prove to be reality and which will remain mere fantasies. What technology from Star Wars do you think we may see in the future? Do you think that humanity will one day be able to travel at the speed of light? Which of the technologies from the Star Wars universe would you like to see in reality? Don't forget to give us a like if you like the video and subscribe to the channel so you don't miss new episodes. Your likes and subscriptions help us create even more interesting content. Thank you for watching. It sounds unbelievable, almost fantastic, but in the world of science, there is a hypothesized particle capable of traveling faster than light. These mysterious objects are called tachyons. Although their existence remains only a theory, tachyons offer scientists amazing possibilities. If they do exist, they could completely revolutionize our understanding of physics, the universe, and even phenomena such as dark matter. One of the major challenges of modern science is to unravel the mystery of dark matter, which makes up about 85% of all matter in the universe, but remains invisible and intangible to our instruments. This is where tachyons can play a key role. Scientists believe that these particles could explain many unexplained phenomena related to dark matter and gravity, such as the structure of galaxies and cosmic expansion. If tachyons do interact with dark matter, they could explain why this mysterious substance remains elusive and why it cannot be detected by light or other conventional methods. For decades, Albert Einstein's theory of relativity has been the unalterable foundation of our understanding of the universe. According to this theory, nothing can travel faster than light, as this would lead to physical paradoxes and require infinite amounts of energy. However, tachyons are exactly the kind of particles that, in theory, can break the light barrier. This not only violates the laws of physics, but also calls into question the very nature of space, time, and cause and effect. If tachyons exist, they could open the door to a new physics where speeds above light are not only possible, but play a key role. One of the most exciting possibilities associated with tachyons is the possibility of time travel. Because of their hypothetical speed greater than the speed of light, tachyons could violate the laws of causality, potentially allowing information to travel backwards in time. This would lead to a scenario where the effect could occur before the cause. For example, an event could be caused by information from the future, creating paradoxical and improbable scenarios that we can barely imagine yet. Another area where tachyons could have a huge impact is quantum physics. In a world of tiny particles, quantum effects become so unpredictable and complex that the old laws of physics simply do not apply. Scientists believe that tachyons may have unique energetic properties that can affect quantum fields and transform them into new states. These particles could be catalysts for the transition of quantum fields to more stable or, conversely, unstable states. This process could radically change our understanding of quantum reality and lead to a revolution in the field of theoretical physics. New technologies, such as the James Webb Space Telescope, have enabled us to look deep into the cosmos and discover structures and phenomena that do not fit within the confines of old theories. Research shows that the structure of the universe is far more complex than previously thought. Giant cosmic formations, such as huge clusters of galaxies, defy the theory of relativity. Perhaps the solution to these mysteries lies precisely in the world of tiny particles, such as tachyons, which could explain why our universe behaves the way it does. If scientists succeed in proving the existence of tachyons, it could change our practical perception of the world as well. Hypothetically, tachyons may have the unique ability to generate energy that would be inaccessible through conventional methods. Such energy could be the key to interstellar travel, capable of overcoming the limitations of the speed of light. This would open the way for humanity to explore distant galaxies and star systems that today seem out of reach. In summary, tachyons are not just a scientific hypothesis, but a potential key to new discoveries and a deeper understanding of the nature of the universe. These particles could change everything from the laws of physics to our understanding of time, energy, and reality itself. Perhaps in the not-too-distant future, we will see stunning discoveries that will show us a world beyond light and space as we know it today. Get ready for revolutionary changes in science. They may be on their way. If you are interested in incredible scientific discoveries and exciting mysteries of the universe, don't forget to subscribe to our channel. Here you will find fascinating videos about cutting-edge research, new hypotheses, and revolutionary theories that could change our understanding of the world. Subscribe and stay up to date with the most incredible discoveries with us.